Welcome to this video. We're going to learn about acceleration, and on this first slide you can take notes at the bottom of page 25 in your handout. So everything you see on the first slide goes on that page. Acceleration is defined as the rate at which velocity changes. So if we want to take this and put it into an equation, we would say acceleration A equals the rate at which, divided by delta t, velocity changes, delta v. This isn't just what acceleration equals, but this is also the definition of acceleration. So we can add right here a third line, give it 3 lines, and again those 3 lines mean acceleration is defined as the rate of change of velocity. Acceleration has direction. Why? Because it comes from velocity, and velocity has direction. The direction can be interpreted 2 ways. The first is this. A negative acceleration would mean you're being pulled to the left or down or in the negative direction. The second way to interpret what negative acceleration means is the velocity is decreasing. If delta v is negative, a will be negative too, because delta t can only be positive. Let's take a look at an example. An object is moving at constant velocity. The acceleration is 0, constant but not 0, or changing. Which of the 3 is the answer? To answer the question, we'll take a moment, pause the video, and see if you can get this answer. Now, the way to answer the question one way is to think about the definition of acceleration. Delta v is in the numerator. If the velocity is constant, then what's delta v equal to? What's the change in velocity if the value of velocity is constant? You can answer this question by remembering delta is final velocity minus initial velocity. And in this case, final and initial are equal because the velocity is constant. So the numerator is 0, and anything 0 divided by anything gives you 0. So the answer is the acceleration is 0 whenever velocity is constant. Okay, on to the next example. A person is running at 5 meters per second to the right. After a little bit of time, they're not going as fast. They're only going at 1 meter per second to the right. Because the person is running to the right, you'll see I've put a positive in front of the velocity. Okay, so now the question is, which way is the acceleration pointing? We know the person is accelerating. How do we know? Because the velocity is changing. But which way does the acceleration point? To the left or to the right? To answer this question, we have to think about which way is the person being pulled. If the person is slowing down, you could imagine that they're being pulled with a leftward acceleration, and that's why they're slowing down. In fact, if the person kept getting pulled to the left, then they would continue to slow down even more. So the acceleration is pointing to the left because that's how the person would have to be pulled to make her slow down in this fashion. Okay, last example. An object's velocity is increasing. Remember, velocity has 2 things. What makes up velocity? It's a speed plus the direction. So let's say that when the person her velocity is increasing, she looks down at her watch, and when the stopwatch shows 0 seconds, her velocity is -6 meters per second. How does the velocity increase from -6? Well, after 5 seconds, maybe it has increased by 2 to -4. Even though she's gone from 6 to 4, it's an increase because she's less negative. So the velocity could increase again after 5 more seconds. Her velocity, let's say, is -2. The velocity is increasing. Now the question is the acceleration positive or negative? Well, to answer that question, you think, is the velocity increasing or decreasing? Acceleration is delta v over delta t. Time can only be positive. In this case, the change in velocity, the the change is positive because the velocity increases. So if delta t is positive and if delta v are positive, then the acceleration is positive too. So the answer is the acceleration positive or negative? The answer is positive. Why? Because delta v is positive.